we were done with conduction already, convection. Now we move on to radiation. So between the sun and the earth, there's a space. Okay, space is a vacuum with no particles in it. So this is your space. So conduction and convection cannot happen in a vacuum because they need particles. So how does heat from the sun reach the earth? That heat reaches the earth by radiation. So what is radiation? Radiation is when the source of heat energy is transmitted in the form of electromagnetic waves, specifically infrared radiation. So instead of using particles, you're using electromagnetic waves. So these are not particles, these are waves. You have not learned about waves yet, but you will learn it in the future. For now, you just have to memorize this definition. Okay? So all hot objects radiate heat to the colder surroundings. The hotter an object is, the more heat energy it radiates. Okay, you're always radiating heat. Heat transfer by radiation is affected by two things: the color and the texture of a surface. Black and dull surfaces emit, so emit is giving out, and absorb radiation well. So if you emit radiation, it's a good emitter. You emit heat well, it's a good radiator. If you absorb radiation well, it's a good absorber. White and shiny surfaces do not emit radiation well and reflect radiation instead of absorbing it. So I have two colors here, black and white. Black is good for radiation, white is bad for radiation. Okay, let's look at some uses. So have a shiny metal teapot. So because it's shiny, it's a poor emitter of heat. Because it's a poor emitter of heat, the heat will stay inside the pot for a while. So you don't lose heat to the surrounding. Okay, so the heat will just stay inside. Because it's shiny. Shiny aluminium foil helps keep food warm also. And heat sinks found in electronic equipments are also painted black so that the heat escape out of it faster. Okay, you don't want your PC, for example, your electronic equipment, to be warm, to get overheated. So that's why you usually use a black painted object so that the heat will escape faster. Okay, so it will emit heat faster. So if you want to lose heat faster, you color it black. If you want to keep the heat, you color it white. So solar panels are always colored black because you want the heat to go in. Okay, you want the heat to be absorbed easily. So you color it black because black is a good absorber of heat via radiation. Wearing white in the summer should, in theory, be cooler than wearing black, as more of the incoming heat is reflected this way. Okay, so if you want to keep cool, you're supposed to wear white because it reflects the heat. Okay, so just to summarize, you had three types of thermal energy transfer: conduction, convection, and radiation. Conduction was mainly for solids, and heat moves from one particle to another by vibration or collision. Convection is mainly for liquids and gases. So in here, heat moves due to difference in density, where one becomes less dense and the other becomes more dense. Radiation is mainly for energy through matter, so this is by waves. Okay, so there's no particles involved for radiation. Very good example that shows all three types of thermal energy transfer. Thermal energy transfer is a vacuum flask. Okay, what's a vacuum flask? It's those thermos that you sometimes bring around to drink. Thermos. Yes, you know what a thermos is. Okay, so in a thermos, this is how it actually looks like. You have the plastic stopper, so this is how you close it, where you put the drink inside, and then you actually have a layer. Okay, so let's look at this one by one. So the first one, the plastic stopper is a good insulator of heat. So little heat passes through by conduction. So you want to keep your drink hot. Yes, inside. So because you have a plastic stopper, it's plastic, right? Conduction, your drink will stay warmer inside because heat is not lost by conduction. So you have no conduction via the top because you have a plastic stopper. Number 2, the gap between the two layers of the thermos. So here you have a layer, here's a gap. Okay, so this gap has air. Okay, it allows air there. Because there's a gap, no heat can pass through by conduction or convection. Okay, so heat loss via the surface of the thermos is minimized by conduction or convection. The inside of the glass wall is silvery. If you open it and look at your thermos, the inside is usually silvery, so that it does not lose heat by radiation. So it reduces radiation. Lastly, the outside glass wall is silvery also usually compared to the inside, and it reflects back any radiation that does get emitted. Okay, so here you can see 3 different ways to stop heat loss in a thermos. They try to stop it by conduction, by convection, and by radiation. Okay, so that's it for today. That was a lot, but we have to finish it. So thank you for listening.